So let's continue with problem 3, force acceleration 2. And we finish the first part to draw the diagram for the wheel AP and phi equation, and we assume no slip wheel AP, so that we have another equation AAX equal to phi alpha AP, which is equation 3, and we plug that in equation 1. So we have two new equations, 1 and 2, and we still have 3 unknowns, 2 equations, so we cannot solve. And with that, we draw another diagram for unbalanced wheel OG. So next step, draw diagram for wheel OG, and this is an unbalanced, and Rafa about O. So when you have that, you can go ahead to draw two wheels the same. Equal to, so basically that is, we're talking about free body diagram equal to kinetic diagram. So you have that here. And the center rotate about point O, so we have point O. But this is unbalanced wheel, they have a something missing on the other side. It's like a pizza, and we eat one part of the pizza, make the pizza become unbalanced. So with that, the center of mass, move to the right. G. So the left side, it will be free body diagram, and we isolate everything surround this body, and you can see it rotate about pin O. O is a pins thick, so as you can see, if you remove that pins out, it will be OX or Y. We also have the weight, it's not O, it's at the center of mass G, and they have a couple 2,270 foot-pounds, and then the tension of the cable. So that those are the forces and couple apply on this unbalanced wheel. So let's write down the weight. Keep in mind is at the center of mass, not at all, because this is unbalanced. So that will be 644 pounds. It's given. And the cable in the tension in the cable is, as you can see, hooked to B, and it vertical. So you have that tension vertical there, point B here, and the tension of the cable go up. Tension. And that's the same tension we have for above. So it's not a new one, because as you can see, hooked to the smooth pulley, the yellow one there, and that one is smooth, it means no friction, so it only changed the direction but not the tension itself. So that is T, and at O pins, like I say, we have to OX or Y. We have OX or Y, so you can assume OY, and then we have OX. Of course, you can assume it go to the right, not a big deal. Unknowns, we can assume whatever. And then what else we have? A couple, and this couple is, let's see, clockwise or counterclockwise. It's clockwise. It's clockwise. So you have a couple C clockwise 2270, and that will be a foot-pound. And that's what all we have on the free body diagram. Now in kinetic diagram at G, all way at G, keep that in mind. So you have G, and you can see it rotate around because Rafa. So G rotate around here. So they have both component MHX, MHY, because it can go up and down, left, right. See that? So you have MAGX AGX, and in that case, as you can see M equal to 20 for OG, so it will be 20 AGX, and just put point B it outside there. And then we have also go up and down, so we have MAGY at that instant, MAGY, and that equal to 20 AGY. And then it rotate about O, so we have clockwise, so we have it I G alpha, and in this case equal to IG for that 800, so it 800 alpha, in this case alpha OG for that unbalanced wheel, so it's not alpha, there are two alpha in here, right? So alpha AP and alpha OG, so that have three terms. And then go ahead to write equation. We already have what, three equation already. Let's make equation 4. Equation 4. Let's make equation 4. Let's sum all the force in x direction equal to MAGX. So from that we have negative OX on the left, and then the other side it will be MAGX, so it will be 20 AGX. Now this is a little bit slow to recall. You see that G about O is Rafa, and when it Rafa, if I draw it down here, if you recall, when it Rafa, we draw the Rafa body, that is O and G, right? So when it Rafa body, you have two components of acceleration. The first one is A G normal, and when it alpha go that way, alpha OG, and we have it A G tangential, two components. And if you look at that compared to here, you can see AGX actually it is normal components, AGN, see that? So it actually, as you can see, when we have that one here, it actually equal to AGN normal. And if you recall, for the AGN, it equal to omega square R. So we will have 20 omega OG square times the radius, in this case, time R G relative to O. So we can plug in. Let's put the dimension here, 5 feet and 10 feet. So you can see that one here is 5 feet, and that one here is 10 feet. So from that we can rewrite that equation as here OG equal to 4 radian per second. So 4 radian per second, and then R 5 feet. So you have 20 times 4 square, 16 times 5. So you can have the OX. Okay, so would you have that OX? So, and it's negative here, by the way. It's negative in that area. So you cancel out. So you can have OX equal to, it could be a big number, 4, 16 times 20 times 5, so it will be 160 pounds positive. So go to the left. So that is OX. Now we have another equation. We don't name that equation because we already find the OX. So don't make that number that equation. So move on to the next one. Is sum of all the force in X direction. It equal to MAGY, right? So that down here. So you have OY plus T minus the weight 644 minus 644 equal to MAGY going down, so that you can see it will be negative, and because we assume positive, go up AGY. And because, as you can see, AGY, like I say here, it equal to HET. It HEY component in there, right? And this one equal to HEX. We already talking about. So from that, tangent with the direction, so we can replace that with alpha OG times the radius of G relative to O. So from that we can have an equation as reduce the negative. So we have 644 minus OY minus T equal to 20 times 5 alpha OG, and it equal 5 times 20. So it will be 100 alpha OG. So that make that equation number 4. Number 4. Okay. And then we have another equation, moment. And by the way, if you go to the solution in PDF, we make moment about point G, about point O, the center. But here, I take moment about point G and assume clockwise positive and equal to IG alpha. So from here, we can have 200, the couple on the right side, 2270 positive. OX, OY, OX go through G, so it's 0. OY, so it happens to be plus, and that a little bit different in the PDF solution. OY times 5, and you can see that, times 5. And then you also have negative T times 10, negative T times 10, negative T times 5, sorry, because that about G. So 5 feet, because about G, as you can see, and that is counterclockwise. The weight go through T, so it's 0. So that all we have on that side, and then on the right side, it will be easier, just IG alpha, so it will be 800 alpha OG. Let's make that equation number 5. Okay, now go ahead to see how many unknowns we have. Here, we have 2 equations, 3 unknowns. How many additional unknowns we have here? Okay, so let's write another unknowns so that we can see. Here, we have 1, 2, 3, right? And then we have 4, T already have 5 alpha OG, 5 OG. So 5 unknowns, 4 equation, 5 unknown, 4 equation. Let's write down, otherwise we forgot, right? 4 equation, 5 unknowns. What are the unknowns? Let's write out. Unknowns, as you can see, tension of the cable, friction force, alpha AP, and then here we have OY, OY, we have alpha OG. So 5 unknowns total. 4 equation. 1, 2, 4, 5. 1, 2, 4, 5. So 1, 2, 4, 5. So what will we do? Give up? Turn off the camera? No, don't do that. So let's work out one more equation and then, right? We need one more equation. So, as you can see, one thing that we don't talking about, these two body, two wheel hooked together. We need to find out the kinematic relationship. As you can see, point A hooked to point B. So whatever B moving, A moving together. How is A moving? As you can see, A move to the right horizontally, and the tension of the cable here go hand in hand, go vertical down. Then the components going down in B. So if you have here AX in X direction, it will be equal to ABY because they hook together. And the ABY, if you recall, at B also Rafa about O, also Rafa about O. So let's point B there. So you also have two components, the normal components ABN and the tangential component ABT, and actually it will be ABT equal to AIX. Everyone okay? So because they one AIX go to X direction, ABY go down vertically, and ABY happen to be a tangential components because they, you see, the same direction in there. So with that, we can have, the keyword is kinematic relationship. It's very important, kinematic relationship, because two work together, two bodies work together. We have to find out what is the relationship there. Kinematic relationship. And the bottom line for the kinematic relationship is you get the relationship between the unknowns already there. You don't introduce another unknown. For example, here, these two, you can introduce the velocity of A in the X direction equal to velocity of B in the Y direction. But that velocity, it introduces another unknown. You don't want to do that. You want to introduce new equation without introduce new unknowns, right? So as you can see from here, I have AX equal to ABY. But that nothing to do with the 5 unknown in here. So we have to make that relation to that 5 unknowns. And you can see AIX is what? AIX equal to, for the wheel, AIX for the wheel, it equal to, because we assume it no slip wheel, so it's here equal to 5 alpha AP. Equation number 3, right? So from that, we can have 5 alpha AP equal to ABY. Actually, it is ABT. Tangential components for the Rafa body OG, the wheel OG. So it also equal to ABT. So it's equal to alpha OG. If we talk about the Rafa body OG, times the radius. So it equal to alpha OG times the radius of B relative to O. Keep that in mind. So it will be 10. B relative to O is 10 in here. See that? 10. So not 5, but 10. That is the key in here. Times 10 feet. So what does that mean? I have a new equation here equal to alpha AP equal to 2 alpha OG. And that, let's set that it equation 6. And now you have equation 1, equation 2, equation 4, 5, 6 equation, 6 unknowns, right? So you You can see more detail in the PDF, but I can say solve equation 1, 2, and then 4, 5, and 6, right? So that 1, 2, 4, 5, and 6. So what you have is set up that. So we have, you will have T equal to 165.3. So that's the first one, pounds tension, and the second one is friction force equal to a positive number 17.71 from that equation, 1771 pounds, because it's positive, so same as our assumed direction, go to the left, so it will be go left. The next one is alpha AP, so you will have alpha AP equal to 5.90 radian per second square, and it will be positive, so clockwise rotation, same as our assumption. Alpha OG double of that based on equation 6, as you can see there, so it will be it will be half of the alpha AP, so we have 2.95 because 2 alpha AP equal to 2 alpha OG. 2.95. Let me write very good in here. 5 radian per second square. Also clockwise. And then we have in terms of force, you have OY, right? OY. You find out equal to 183.5 pounds. Go up positive. And that 5 equation, 5 unknowns. Are we done with this problem yet? Oh, unfortunately not yet. We assume no slip wheel. You have to check whether your assumption is correct, right? Check no slip wheel assumption. So that is a little bit here. Check. No slip wheel. In that case, the wheel AP assumption. Okay. What is the equation to check? If it assumption FF less than mu sub Sn, right? So you have that, and N we already find out 161, and the mu sub S for this one equal to 2.5. So make down here, you have FF equal to 17.71 pounds. Let's see mu sub Sn. Mu sub Sn equal to 0.5 times 161, and that equal to 80.5 pounds. And 17.71 for sure it's less than that. So assumption is good. No slip wheel. Good. No slip wheel assumption valid, and that should be a happy face. It means that we don't have to continue slipping wheel, just something like we did in problem 4 force acceleration 1. If you want to go back to check that if it, what happened if the FF is more than mu sub Sn, then you go to slipping wheel, and then FF equal to mu sub Kn. Go back to that, check that equation. Because of that, so we can box for the answer. And the question asked is, does wheel AP slip? What is your answer? No, right? So with that, very long problem, a lot of work to do, and I can tell you, if you can master this problem, everything about force acceleration you can solve. And with that, we done for today's class. Thank you.